Welcome back. In the last video, we saw an end-to-end Scikit-learn workflow. Now we're going to break that down and jump into each of those steps individually. And the first one is getting the data ready. And you've probably noticed I've kind of listified this just because I'm a bit of a nerd, so that way we don't have to scroll right back up to top to see what we're covering. We can just put this here, this little cool trick, wherever we want in the Jupyter notebook, because we've run this cell and instantiated this as a list variable. So we're going to tick off getting the data ready in this section. And another thing we probably should have done right at the top, we can usually do it in any machine learning notebook that we're working on. So we'll just type in here, standard imports, just so we have them ready at our arsenal. We've already done NumPy, pandas as PD, import matplotlib dot pyplot as plt. And then we'll do a little matplotlib inline, so our plots appear in the notebook. So this is just 3-4 lines of code that you can run at the top of most notebooks, and then you'll see throughout as we start to use different scikit-learn functions. We could also start to put them up the top too, but we'll leave it at those for now. So let's go down to where we were. This section, we're getting our data ready. Now the reason we have to do so is because most of the time data doesn't come ready to be used with a scikit-learn machine learning model. Now, we'll create a little heading. So we have to get it ready. So getting our data ready to be used with machine learning. And then the three main things that we'll have to do, number one is, let's communicate a bit better, Daniel. Three main things we have to do is one, split the data into features and labels, usually X and Y. This is what you'll find them called generally if you're on the internet somewhere, or the Scikit-learn library usually calls features X and labels Y. And then number two is filling, also called imputing or disregarding missing values. So if any of our rows in our data set have missing values, if there's any incomplete fields, we may have to fill them up. Or we may have to get rid of them completely, those samples, because a machine learning model can't learn when there's nothing there. You'll see it throws an error. Then the final one is converting non-numerical values to numerical values, also called feature encoding. AKA, if we have, say we have our car sales, we need to turn that into Markdown. Beautiful. So if we have our car sales data and we have Toyota, we have the color, etc., etc., a machine learning model can't understand Toyota. What have I done there? Can't understand Honda, can't understand red. We have to turn these into numbers. So we'll see how to do that in this section. All right. Well, we need a data set to begin with first, and I think we still have our heart disease data set imported. So let's check that. .head. Wonderful. So we'll do step one first. We've seen this before in our workflow, but we'll just get a succinct version of how to actually do it. So in this case, we want to use the feature columns to predict Y. So what are we doing here? We're keeping it nice and simple. We'll use pandas X equals heart disease dot drop. So we want to remove the target column along axis 1. And now remember, in a pandas data frame, axis equals 1 means this axis here, or the columns axis, and axis 0 is the rows axis. So X is now going to be every single column except for target. Wonderful. And you know what our Y is going to be, because that's the labels of our machine learning problem. Our Y is going to be the target column, heart disease, and we'll select it like that. We'll look at Y.head. So we'll see the first 5 samples. Wonderful. We go back up here, 1, 1, 1, 1, 1. We see Y is the same. Beautiful. Now the next thing we have to do is split data into training and test sets. So in machine learning, one of the most fundamental principles is never evaluate or test your models on data that it is learned from, which is why we split it into training and test sets. So Scikit-learn has a convenient function for allowing us to do that. So split the data into training and test sets. Remember right back at the start when we were going over concepts, if you're looking at the test data, it's like looking at the final exam before you've looked at the practice exam. Not what you want to be doing, right? If the professor accidentally leaked the final exam, everyone would be getting perfect marks and no one would be actually learning anything. So we want to, from Scikit-learn.model selection, Scikit-learn has a fair few different modules, but we'll see some of the most useful ones. Import, train, test, split. Beautiful. Now, when we call train test split, it's going to return 4 different values. One is xtrain, one is xtest, one is ytrain, and one is ytest. So let's see what happens. Train test split, and now we pass it our x data. Let's see what it says actually. Split arrays or matrices into random train and test subsets. Beautiful, that's what we want. We want some data to train on and we want some data to evaluate our machine learning models on. So we'll pass it our features and we'll pass it our labels and we'll define the test size as being 0.2. So let's see what happens. Wonderful, that runs smoothly. And let's check out the shapes of our new matrices, because remember, our data here is really just a matrix in a data frame, or a NumPy ND array in a data frame. So we want xtrain.shape, we'll test xtest.shape, ytrain.shape, and finally ytest.shape. Let's see this. Okay, so 242 with 13 columns, so 242 by 13, then 61 by 13. Okay, this makes sense. So if we look up here, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 different features. That's why our xtrain variable is 242 by 13. But where did this 242 come from? Well, that's because we've decided here that we want our test data set to be 20% of the overall data. So let's have a look at this. If we go x.shape, because x is before we split it, right? We got x up here. x.shape is 303. So we have 303 samples total. Let's just check that. 303 samples total, and 80% of them are going to be training data for the machine learning model. So if we go train.shape, we want to times that by 0.8. So 242.4. We add these together. 242 plus 61. All it's done is it just rounded it down and automatically carved the other 20% into the test set. And it's done the same for ytrain and ytest. Beautiful. Now, we've split our data into training and test. The next step, we go back up here, is to fill it, or converting it, making sure it's all numerical. So we might see this, maybe we do that, we fill it first. Yeah, that's a good idea. We'll come back and we'll do that in the next video. So maybe have a go at playing around with one of our CSV files and splitting it into training and test data, or splitting it into X and Y first, and then change around this parameter here to see what happens when we change that to 0.3. What do you think will happen if I press Shift Enter here? The numbers will change. Maybe you want to play around with a different fraction. Otherwise, I'll see you in the next video and we'll look at how to fill some missing data.